Hi friends, today we are going to discuss about the first chapter in chemistry, that is chemical reactions and equations. In this topic, we will understand about chemical reactions, chemical equations and how to balance a chemical equations and different types of chemical reactions. I think you have already learned about physical changes and chemical changes in your previous classes. Let us just revise that. I will give you some situations and you have to tell whether the changes are physical changes or chemical changes. Let us look at the table and you try to identify them. The first one is melting of ice. What do you think? Is it a physical change or a chemical change? Yes, you said it right. It's a physical change. Why melting of ice is considered as a physical change? Why? Because there is no new substance is formed and this change is reversible. Why? Because when ice melts, you get water. When you freeze water, you get the ice back. So it's a physical change. Now let us look at the second one, curding of milk. What do you think? Is it physical or chemical change? Yes, it's a chemical change. Why? Because here this change is irreversible and here a new substance is formed. Let us look at the third one, burning of paper. When you burn a piece of paper, you get ash. You cannot make paper back from ash. So we consider that it is a chemical change. Now what about ripening of fruit? It's also a chemical change because this process is irreversible. Now what about melting of wax? Melting of wax is a physical change. Why? Because when you melt a piece of wax, it just turns to the liquid state, but when it solidifies, you get the solid wax back and here no new substance is formed. But you should make sure that burning of candle is a chemical change. Why? Because when a candle is burned, light energy along with gases are formed. So burning of candle is considered as a chemical change. In this topic, we are going to discuss about only chemical changes. Whenever a chemical change takes place, we say that a chemical reaction has taken place. Now let us look at what are the characteristics of a chemical change. In this topic, we will take some examples and we will try to understand the characteristics of a chemical reaction. First of all, you know that when you combine hydrogen and oxygen together, you get water. Let us look at the reaction. When hydrogen and oxygen combine together, you get water. Here, what is the physical state of hydrogen? You know that physical state of hydrogen is gas. What about oxygen? It's also gas. But what about the product water here? Here, the physical state of water is a liquid. So from this experiment, what we conclude? We conclude that the physical state of product is entirely different from the physical states of reactants. So during a chemical reaction, there can be a change in the state of reactants. Now let us look at another example. When you heat ferrous sulfate crystals in a test tube, you get ferric oxide and sulfur dioxide and sulfur trioxide gases. Here, you know what is the color of ferrous sulfate crystals? The color of ferrous sulfate crystals are green. But when you heat it, it becomes ferric oxide, which is reddish brown in color. So here, in this chemical reaction, a change in color is observed. Also in this reaction, you can see the nature of other two products, sulfur dioxide and sulfur trioxide. They are gases. So from this reaction, we conclude that during a chemical reaction, there can be a change in color. At the same time, there can be some evolution of gases. Let us look at the third one, the reaction between calcium oxide and water. When calcium oxide is treated with water, you get calcium hydroxide. But you can see that in this reaction, a large amount of heat energy is released. So, in a chemical reaction, there can be a change in temperature. Now, what about the reaction between silver nitrate and sodium chloride? When silver nitrate and sodium chloride are reacted together, you get silver chloride and sodium nitrate. Here, silver chloride is a precipitate. What do you mean by precipitate? In this reaction, silver chloride, which is white in color, which is insoluble in water, and that will be settled at the bottom of the test tube as a precipitate. So, from all these reactions, we conclude that during a chemical reaction, there can be a change in state, there can be change in color, there may be evolution of gases, there can be change in temperature, and sometimes precipitate also will be formed. So, these are the characteristics of a chemical reaction. In this session, we are going to understand how to balance a chemical equation. First of all, let us consider a reaction between hydrogen and oxygen. You know that when hydrogen and oxygen reacted together, you get water. So, this reaction can be expressed as hydrogen plus oxygen gives water. You see, here the reaction is expressed using words. So, this type of reactions are called word equation. Okay, it's an equation, it's a reaction. This reaction is represented using words. So, this equation is known as word equation. Now, if you replace the words by using chemical formulas, you get a chemical equation. Now, let us see how to write the chemical equation of this reaction. It is H2, that is for hydrogen, oxygen, that is O2, gives H2O. H2 plus O2 gives H2O is the chemical equation for this particular reaction. Here, to the left side of the arrow mark, there are hydrogen and oxygen. These are known as the reactants. Now, to the right side, RHS of the arrow mark, it is H2O, that is known as the product. So, in a chemical reaction, or when you write a chemical equation, to the left side of the arrow mark, there will be reactants, and to the right side of the arrow mark, there will be products. You know that reactants combine together to give you the product. Now, let us compare. Now, I told you, now this equation becomes a chemical equation. Now, let us see what are the number of atoms of each element present on either side of this arrow mark, that is on LHS and RHS. Let us see. Let us count and compare the number of each element on LHS and RHS. Let us see what are the elements here. In this reaction or in this equation, the elements are hydrogen and oxygen. Let us look at what is the number of hydrogen atoms on LHS. You can see that it is 2 on LHS and it is also 2 on RHS. You see, on LHS, H2 is there. So, there are 2 hydrogen atoms. On RHS, the product is H2O. So, what is the number of atoms, hydrogen atoms? It is 2. So, on LHS and RHS, the number of hydrogen atoms are equal. Now, let us look at what is the number of oxygen atoms on either side. What is the number of oxygen atoms on LHS? It is 2. You are right, because it is O2. On LHS, it is H2 plus O2. So, what is the number of oxygen atoms on LHS? O2. So, there are 2 atoms. Let us look at what is the number of oxygen atom on the RHS. There is only 1, because on RHS, there is only H2O, 2 hydrogen and 1 oxygen. Now, look at the table, you can understand the number of hydrogen atoms are equal on LHS and RHS, but the number of oxygen atoms are not equal. Now, we say that this reaction or this chemical equation is not balanced, or this type of equations are also known as skeletal equation. Why? Because here number of atoms of each element on the reactant side and the product side are not equal. In this example, the number of oxygen atoms on LHS and RHS are not equal. So, we call this equation as an unbalanced chemical equation. Now let us see, according to law of conservation of mass that you have learned in previous classes, the total mass of products or total mass of elements on the product side should be equal to the total mass of elements on the reactant side. So the total mass of elements or atoms on LHS and RHS, that has to be equal. But here it is not equal. That's why we call it this equation as an unbalanced chemical equation. Now let us try to balance this chemical equation. Let us see how to balance it. It is given that H2 plus O2 gives H2O. That is an unbalanced chemical equation. Now let us try to balance it. When you balance it, you have to remember that you are not supposed to change the chemical formula of the compound or the elements. For example, see, how can you make the number of oxygen atoms 2 on RHS? You are not supposed to write the product as H2O2. Then it will be very easy, isn't it? On left side there will be 2 hydrogen and on the right side also there is 2 hydrogen. But that is wrong. When you represent product as H2O2, it becomes another compound. H2O2 is hydrogen peroxide. So you are not supposed to change the chemical formula of the compound. So what you can do? You can just add numbers just in front of the compound or the chemical formulas. So here the first step, how can you make oxygen 2 on RHS? You can just put 2 just in front of H2O. Now the equation becomes H2 plus O2 gives 2H2O. Now what is the number of oxygen atoms on either side? On left side there is 2, right side also 2 oxygen atoms. Now the number of hydrogen atoms, that is disturbed. You see, what is the number of hydrogen atom on the left side? There is 2, and what is on the right side now? It is 2H2, that is 2 into 2, 4 hydrogen atoms. Now let us try to balance the number of hydrogen atoms equal on either side. So on RHS there are 4 hydrogen atoms and on the left side there is 2 hydrogen atoms. Now how can you make the hydrogen atoms 4 on LHS? Just add 2 in front of hydrogen. Then you will be getting 2H2. The number of hydrogen atoms on the LHS become 4. Now we say that this chemical equation is balanced. So what is the chemical equation, balanced chemical equation for this reaction? It is 2H2 plus O2 gives 2H2O. That is the balanced chemical equation for this reaction. Now let us consider one more example. Let us take the example of reaction between magnesium and oxygen. You know that when magnesium ribbon is burned in oxygen, or when it is burned, you get a powder that is called magnesium oxide. So the reaction between magnesium and oxygen can be written as Mg plus O2 gives MgO. That is the chemical equation. Let us see whether it is balanced or not. What is the number of magnesium atom on LHS? 1. What about magnesium atom on RHS? That is also 1. But on LHS, what is the number of oxygen atoms? 2 atoms are there because on LHS it is O2. Now what about the number of oxygen atoms on RHS? There is 1. So you have to make the number of oxygen atoms equal. To make the number of oxygen atoms equal, what you have to do? Yes, just add 2 in front of MgO. Now RHS becomes, 2 MgO. The equation becomes Mg plus O2 gives 2 MgO. Now the problem of oxygen is solved. But there arises another problem, the problem with magnesium. What is the number of magnesium on RHS? 2 MgO, that is 2 magnesium. But what about on LHS? There is only 1 magnesium. Now how can you solve it? How can you make the number of magnesium atoms equal? Yes, just add 2 in front of Mg in the reactant side. Now the equation becomes balanced, and the balanced chemical equation is 2Mg plus O2 gives 2 MgO. Is it clear? Let us take one more example. The reaction between iron and water. Let us look at what we get when iron and water is reacted each other. When iron and water is reacted each other, you get Fe plus H2O gives Fe3O4 plus H2. This is the chemical reaction takes place. That is the chemical equation. Is it balanced? Let us look at what is the number of iron atoms on LHS. there is only one ion on LHS. What about the number of iron atoms on RHS? There are 3 iron atoms. Why? On the product side, you can see it is Fe3O4, Fe3. So, there are 3 iron atoms. So, how can you make the number of iron atoms equal? To make number of iron atoms 3 on LHS, you just add 3 in front of iron Fe on LHS. Now, the equation becomes 3Fe plus H2O gives Fe3O4 plus H2. Now, the problem with iron is solved. On LHS, there are 3 iron, 3 Fe. On RHS, there are 3 Fe. Now, let us look at the next one, hydrogen atoms. You see, what is the number of hydrogen atoms on LHS? 2. What about on RHS? 2. So, they are equal. Let us look at the next one, oxygen atoms. What is the number of oxygen atom on left side? 1. Isn't it? H2O, there is only 1 oxygen atom. What about on RHS? RHS, there are 4 oxygen atoms because it is Fe3O4. So, you have to make the number of oxygen atoms equal on both sides. On right side, there is 4. So, you have to make 4 on LHS. So, what you have to do? You are not supposed to add OH2O4. I told you, you are not supposed to change the chemical formula of a compound. You can just add 4 in front of H2O. Now, it becomes, the equation becomes, what is the equation? 3Fe plus 4H2O gives Fe3O4 plus H2. You see, number of oxygen atoms on left side is 4, number of oxygen atoms on right side is 4. But again, one problem arises. What is the problem? What about the number of hydrogen atoms? It is disturbed. Now, on LHS, what is the number of hydrogen atoms? Hydrogen atom becomes 4H2. That is, 4 2s are 8 hydrogen atoms. But what about on RHS? There are only 2 hydrogen atoms, H2. So, how can you make RHS equals LHS? LHS there are 8, RHS there is 2 hydrogen atom. So, that 2 hydrogen atoms you can make it 8 hydrogen atoms by just adding 4 just in front of H2. Now, the chemical equation is balanced and the balanced chemical equation is 3Fe plus 4H2O gives Fe3O4 plus 4H2. So, in this session, we balance 3 chemical equations. The first one, the reaction between hydrogen and oxygen to give water. The second reaction was the reaction between magnesium and oxygen to give magnesium oxide. Now, the last one, the reaction between iron and water. So, all these chemical equations were unbalanced and we balanced all these chemical equations. I think you understood how to balance a chemical equation.